Hello everyone, welcome back to our live show. Today we are going to talk about some of the important questions that our client have from us. I'm going to go through those questions one by one and I'm going to help you answer those questions. So the first question that we have today is that how many kilowatts are present in 48 volts 200 ampere hour battery? So in order to calculate the kilowatt rating of any battery, the kilowatt is basically the power of the battery. You need to multiply the voltage value to the capacity value and you need to divide it by 1000. So in our case it's 48 volts and 200 ampere hour. You need to multiply those, you will get an answer of 9600, and 9600 then you divide it by 1000, you get 9.6 kilowatt hour. So this is kilowatt hour, we are going to calculate kilowatt. So you need to know how much time you're going to use that battery in any certain applications. For example, if you're going to use that battery for 2 hours, so you can divide it by 2. In our case, let's say we divide it by 1 hour. So our battery can provide, the 48 volt 200 battery ampere hour battery can provide for 1 hour 9.6 kilowatt of power for any particular application. This is that answer. So let's move on to our next question. We have our next question that is basically related to this question as well. So it is, what is the difference between kilowatt and kilowatt hour? Just like I said, kilowatt, when you get discussing about watt is basically the unit of power, while the kilowatt hour is the unit of energy. When discussing kilowatt, kilo is 1000. So kilowatt and kilowatt hour, you need to know that kilowatt is power, while kilowatt hour is capacity or energy. In order to calculate these, basically you need to know what any particular motor or any particular application uses how much power, and kilowatt hour is based on how much hours it can be used for that particular application. Kilowatt is not time based, kilowatt hour is time based. To know more about these differences, you can go to our blog and you can have more in-depth knowledge about this. We have given out examples as well in order for you to understand what is the difference between kilowatt and kilowatt hours. So now we're going to come towards our next question. In our next question, we have that how long will a 48 volt 200 ampere hour lithium battery last? So the calculation is very simple. Basically, you need to take out what is the battery life, how many hours it can be used. So you need to basically divide the battery capacity, the ampere hour capacity, divide by the discharge rate. The discharge rate is basically is in amperes. Amperes measures how many amperes any particular application need or any particular motor needs. So to calculate the discharge rate, you need to divide the power by the voltage of the battery. In our case, let's say we are using 48 volts battery supplying at 1 kilowatt. So the discharge rate would be 1000 watt divided by 48. That is around 20.83 amperes. So now the battery capacity, you remember the capacity is 200 ampere hours. We need to divide that battery capacity by the battery amperes. So we divide 200 ampere hour with 20.83 amperes and we get a roughly about 9.6 hours of backup time. So if we get 9.6 hours of backup time, so for this particular application in 1 kilowatt supply, we can utilize the battery for around 9 or 10 hours. For more information on this calculation, you can go and visit our blog on our website. It is posted on our website, and I'll put a link down below so you can go there and you can have more information on this. So the next question that we have is that can I charge parallel batteries? Yeah, so there is one user, he wants to know that if he can charge batteries in parallel. Basically, yeah, the simple answer is yes, you can charge the batteries in parallel, but there are some things that you need to maintain before doing this operation. First of all, you need to make sure that the batteries that you have connected have the same voltage value. If there is the difference voltage value, we should not recommend, and it is not recommended to connect them in parallel and charge them at the same time. So the second thing is the capacity. They should have the same type of cell chemistry, and they should have the same level of battery capacity. Battery capacity means the ampere hour rating, and the cell chemistry means, like, if they are lead acid batteries, they should be connected in parallel to lead acid batteries. If they are lithium ion batteries, you should connect lithium ion batteries in parallel. You should not perform lithium ion connection with lead acid one. That is a dangerous connection. You can not do that. The next thing to take in mind is balancing. You need to check up if the cell levels are balanced with each other. You need to make sure the charge controller is okay. You have to have safety precautions before doing that. If there are any disorientations with the battery, you need to know that beforehand. And there are like other proper wiring, monitoring, and maintenance. To know more about on this question and know more about this in detail, you can visit our blog on our website, and you can have more information on this question as well. We post all of our questions onto our website, and we post them in our blogs, so you can have more information on any of these answers from there. So let's move forward to our next question. So the next question is pretty much similar to the previous one, but it has a little bit of difference. Like, the question is, can you charge two lithium batteries in parallel with one charger? The short answer, yes, we can charge two lithium iron phosphate batteries that are connected in parallel using one charger. But the charger specification that we will use in this scenario would be equal to the total capacity of the two batteries connected in parallel. For example, if we have two batteries, each is 100 ampere hour rating. So the two batteries connected in parallel will give you a total of 200 ampere hour rating. To charge those batteries, you cannot use the calculations based of 100 ampere hour to measure how many hours it will take to charge the battery. You need to measure based on 200 ampere hour. That is just the difference, and other than that, you need to maintain the other specifications that we already have, like voltage compatibility, balancing, capacity matching. You need to make sure the parallel connections are legit, the common grounding. You need to make sure the charging current is okay, the charger controller BMS supports this. You need to make sure about all the safety precautions, and later on after charge, you need to disconnect the batteries so that they don't have any unwanted charging or discharging. So this is the way you can utilize one charger to charge two batteries. To know more about this, you can go to our website and you can read our blog on this topic as well. We have all of our blogs on all of our topics. So whatever topic that we are discussing here, you can study that topic in detail in our blogs on our website. I'll put the link down below. So we are now going to move towards the next question. The next question we have is, which lithium ion battery is best for electric scooters? So when we are talking about lithium ion batteries have like different type of cell chemistries. The first cell chemistry is lithium iron phosphate. Then we have the lithium nickel manganese cobalt oxide, NMC. We have lithium cobalt oxide, LiCO2, and then we have lithium manganese oxide. And using any of these batteries for any of the lithium battery applications is okay, but you need to know the pros and cons of each battery associated with each application. For example, if we are talking about lithium iron phosphate batteries, there are the pros and cons of using this battery in any application. The first pros being the longer life cycles, good thermal stability, and lowered self discharge rate, while there are some cons like slightly lower energy density compared to the other lithium ion batteries. Let's move on to the next one, the lithium NMC. When we are talking about the lithium NMC, there are the pros of high energy density, good balancing between power and capacity, and these are widely used in electric vehicle applications. And there is the con, that the con of this battery is that this have shorter lifespan compared to lithium iron phosphate batteries, although they have higher energy density. The other one is lithium cobalt oxide. These batteries are basically the batteries having high energy density, but these batteries have their most application in consumer electronics. There are particular no cons to this, but these batteries are very less common in electric scooter applications because they have one of the lowest cycle lives in all of the lithium ion batteries. So lithium manganese cobalt, lithium manganese oxide battery LMO. It's also known as LIMN204. There are the pros and cons of this battery as well. So the pros being good thermal stability, safer than LiCO2, and it is moderate energy density. It has moderate energy density, but the cons are the same, that it has lower energy density compared to other lithium ion batteries. So when we are discussing about the batteries used for scooter applications, so the most probable answer would be using the lithium iron phosphate batteries or the lithium NMC batteries. These are the two best options. To study more about this, you can go to our blog and you can have more information from our website. So moving on, the next question that we have is which is better, lithium iron phosphate or lithium polymer? So when we are discussing about different lithium chemistries, there are different pros and different cons, different advantages and different disadvantages associated with any type of battery that is present in the market. We are gonna discuss about the lithium iron phosphate pros and cons first, and then we will move on to lithium polymer. So the first pro of lithium iron phosphate battery is that it is highly safe. It is considered as one of the safest batteries available in the lithium ion chemistries. It has one of the longer life cycles compared to every other lithium ion batteries chemistries, and it has wide application in energy storage these days. And the third pro would be its stable voltage. Lithium iron phosphate batteries, they basically maintain a strong stable voltage during discharge, providing a more constant power to the load. And then there is another pro, that it has wide operating temperature range. Lithium iron phosphate batteries, they basically come on to the wider side of the temperature range spectrum when we are using it in different application scenarios. So it has the higher extremes and lower extreme. Particularly the general ones have from like minus 20 degrees to 60 degrees Celsius. So this is a good plus point of lithium iron phosphate batteries. Now coming towards the cons of these batteries, there are some cons as well, like lower energy density. Lithium iron phosphate batteries, basically they possess a little bit lower energy density compared to the other lithium iron phosphate batteries, which make them a little bit bulkier and a little bit heavier. And the second con is the higher price. But every good thing comes with a price, so that is understandable, because higher cost of lithium iron phosphate batteries, it's one of the more higher cost than the other lithium ion batteries. But even the higher cost, it has one of the best features available, one of the best cycle life available, one of the best source safety features, stable voltages. So it's a good trade-off. Coming toward the lithium polymer batteries, so there are some pros and cons to lithium polymer batteries as well. We're going to discuss them one by one. So the first pro, it's like high energy density. Lithium polymer batteries, basically they have high energy densities, and the beauty of lithium polymer batteries is that they come in smaller and lighter packs. So they have many applications in automatic guided vehicles, drones, and other stuff. So they are very popular there. And the second pro that they have a flexible form factor. So being a flexible form factor makes them easier to be used into various shapes. They can be made into various shapes and various sizes, and they can adopt different designs depending upon different applications. So they cover a lot of range of applications based on just this factor. And the third one is the good discharge performance, because they provide a high discharge rate. So they are very feasible in any application that use high power demand. So any of the high power demand applications, lithium polymer battery is a very good battery for those. So coming towards the cons of this, that There are some safety concerns when using lithium polymer batteries because they are prone to thermal runaway and they are less stable than the lithium iron phosphate batteries. Lithium iron phosphates are one of the stable batteries, most stable in all of the lithium ion types. So when using lithium polymer, you need to make sure that you are properly handling and properly avoiding any type of safety issues. So you need to make sure you need to handle that battery safely. The second con is that these are shorter life cycles. These batteries have shorter life cycles compared to the lithium iron phosphate batteries, and because of the high discharge rate, it's fairly obvious that it is going to be a less cycle life battery compared to lithium iron phosphate. And the third one is its sensitivity to temperature. Unlike the lithium iron phosphate batteries, these batteries, they exhibit performance issues and they have reduced cycle life in extreme temperatures, so they are not recommended for a wide range of temperature applications. So this is it for this question from my side, but if you want to have more knowledge on this, you can go to our website and you can read our blog. So coming towards the next question from our one of our clients is that what is the advantage of using 48-volt battery? Basically, when you are using a 48-volt battery, there are many advantages associated with using a higher voltage system as compared to a lower voltage system, because in the higher voltage system you would have one of the following benefits. You would have efficiency in power transmission, you would have reduced current stress, you would have more motor application efficiency. If you are using electric meters or electric motors, you will have a more stable system integration, because many of the inverters available in the market, they are available at a higher voltage range rather than a lower voltage range, and it makes it more good because using a higher voltage value like 48 volts instead of 24 volts or 12 volts makes the current stress less on the whole system, because the higher the voltage, the lesser the current and the lesser the damage to the wire, the lesser the losses. So you get the idea. So some of the more benefits is like more wide grid compatibility, and it has more applications in energy storage systems, being more inverters and more easier integration with all of the different kind of installation batteries. Also, 48 volts is basically one of the standards available in the market. So any of the systems, you would find it rather easier to support 48 volts rather than choosing 36 volts or 72 volts perhaps. So also there are safety considerations and there are also cost efficiency associated with this kind of product. To know more about this in detail, you can go to our website and you can read the blog. The next question is one of our clients, and he's asking that if there is a higher ampere hour lithium battery, and is it better than the lower ampere hour lithium battery? To answer that question generally, yeah, using a higher ampere hour lithium battery makes you have more capacity and more working hours than compared to a lower ampere hour capacity. But there are some factors that you need to take in account when you are using a higher ampere hour capacity. We are going to talk about those factors one by one, and I'm going to tell you what are the advantages or considerations that you need to do with when using higher ampere hour lithium battery capacities. So the first one is the advantages is extended runtime. It's fairly obvious that when you are using a higher ampere hour capacity, you are going to have more working hours compared to the less working hours on a lower voltage battery, on a lower capacity battery. So the second advantage is that it is suitable for high power devices. For example, if any power device utilize a lot of current, it's better to have a more ampere hour capacity battery than using a small ampere hour capacity battery. And there is another factor that it will provide you reduced discharge depth. Like for example, using a higher ampere hour battery for a given load, basically it can result in shallow depths of discharge. So the shallower the depth of discharge is, makes the longer the cycle life. And there are also flexibilities in application. For example, like you're going to use if you're going to have a bigger battery with a bigger ampere hour capacity, you can use that battery for even the lower capacity used applications as well. But if you are already having or already using a small ampere hour capacity, and if you get the need to use it at a bigger ampere hour capacity application, you cannot use that. So these are some of the benefits. But while these benefits exist, we need to take in some considerations as well when using a bigger ampere hour capacity. Those considerations include, first of all, the size and the weight, because with higher ampere hour capacities, the size and the weight of the battery will increase drastically. So you need to take in account that with the higher size and with the higher capacity, the cost will increase as well. So you need to take in account the cost as well. And then next would be the charging time, because if you are using a higher ampere hour capacity battery, it will definitely need more time to charge than compared to a lower ampere hour capacity. And then there is the cycle life. So the cycle life is pretty much that depends upon how the battery is utilized in your application. If you are using shallower discharges, then the cycle life can be improved. But the overall cycle life, basically that depends on various factors. So if you're gonna if you want to know about those, you can go to our blog, and you can go to our website to the blog to visit and study more. So you can have that there. The next question from our client is that, is 48 volt faster than 36 volt? Like, this is a question where there is no like a particular answer, like if 48 volts is faster than 36 volt. That really depends upon, like, if you are talking about any certain application. To say, let's say we talk about a motor application in this case, right? So if we talk about a motor application, so the speed of the motor is basically directly proportional to the voltage applied to its terminals. So in this case, if we use a 48 volt batteries instead of a 36 volt battery on a same motor, that motor speed is going to be faster than compared to 36 volt battery. So we can take that into this account. We can also talk about this in the terms of power output. Like, power output is based on voltage and current, right? So if you're using watts as a multiplication factor between voltage and current capacity of any battery, the voltage is a factor that will definitely increase the power, and with the power you get the advantage of achieving higher speeds and better performance. When we are talking about efficiency of overall a 48 volt battery is better than 36 volts because of the higher compatibility available in the market with certain type of applications. So the higher the voltage it provides, the more stability and the more higher efficiency. When we are talking about the battery performance, in terms of battery performance, 48 volt battery will perform better than the 36 volt battery, but this factor cannot only be used to determine if you use 36 volts or if you use 48 volts, because if there is a certain application that can be run at a 36 volt battery, you cannot really use 48 volts for that. And if there is a certain application that will only require 48 volts nominal voltage, or a range between like 48 volts, near to 48 volts, then you're going to use a 48 volt battery. You cannot use 36 volts for that. So that's it. I just explained, like, for example, if there is an example of a motor controller compatibility, if a controller supports 48 volts, you cannot use 36 volt for that. So to study more on this topic, you can go to our website and you can read the blog. So the next question is, it's kind of the same as one of the previous questions that we did at, is a 200 ampere hour lithium battery good? As I explained before, using any higher ampere hour capacity battery comes with its own advantages and its own considerations. I would not say disadvantages, because when you are talking about any ampere hour battery, there is a general term saying that the bigger the better, right? So if you're using a 200 ampere hour capacity battery compared to a 100 ampere hour capacity battery, you are definitely going to have the benefits of longer operation time. You're going to have the benefits of higher densities, high capacity availability, high current discharge, and other factors associated like that. But there are going to be some considerations as well, like if your application supports a 100 ampere hour battery and you are using a 200 ampere hour battery for that application, then you're going to have to sacrifice on the size and the weight, because the size and the weight is going to be higher. For more information on this type of topic, you can read our blog on our website. I have put the links down below. The next question that we have is from our client. He is asking that, can I use a 72-volt battery on a 48-volt controller? To generally answer this, no, you cannot use a 72-volt battery on a 48-volt controller, because 48-volt controller is basically designed to support at the application range, the battery range between 48 volts. So if you are using a 72-volt battery and you're going to use a 48-volt controller, it's going to have some problems. The problems, some of the problems I'm gonna talk about here, and for more problems you can visit the blogs. The first problem is going to be the voltage mismatch. The controller that you are using is at 48 volts, but you want to use it for a 72-volt battery, so there's going to be a voltage mismatch, and that can cause some problems. The second problem is going to be the voltage protection. So if you're using a controller that is 48 volts, but you are using it at a 72 volts battery, that requires 72 volts to like get it charged or get it controlled. So there is over voltage protection available in many of the controllers, right? So it's not going to allow you to connect to that battery in a good scenario, or in a bad scenario it can go the other way, and it can cause any type of damage. So the next problem is going to be compatibility issues. Yes, the controller algorithm and the components that are associated with the controller are programmed to be used with a 48-volt battery instead of a 72-volt battery. So if you're going to put a 72-volt battery to that, it's going to create some problems, and it's going to create some compatibility issues. And finally, there are many safety concerns when you are dealing with lithium batteries, or batteries in a general, with any type of controller. So you need to make sure that you use the batteries and the controllers that are compatible with each other. So to study more about this, you're going to have to read our blog on our website. You can go to the website. I have put the link down below. So let's move on to our next question. Our next question from our client is, what does 13.5 kilowatt hour means? Basically, kilowatt hour means in general, kilowatt hour means the capacity of any battery multiplied by its voltage, and the answer is energy. This is energy of any battery that you can utilize for any application for a certain number of hours. So it is calculated in kilowatt hours. Watt is the unit of power, kilo is for kilo there, 1000, and hours is for how many hours you can utilize this battery. So if you're talking about 13.5 kilowatt hours, that means it would be certainly a battery that has a certain amount of voltage multiplied to a certain amount of capacity to make it a 13.5 kilowatt hour solution. So this is that. To study more on how to calculate kilowatt hour ratings, you can visit our blog. We have the mathematical proportions there. You can check with the mathematical formulas, and you can also know how to calculate kilowatt hour ratings of any battery in particular. The next question, being a battery manufacturer, what is the difference between Powerwall and Powerwall Plus? What I believe here from this question is that we have our own Powerwall series, right? So the general term that the client has quoted here is, I believe, for Tesla Powerwalls, because Tesla Powerwalls have two kinds of model. There is Powerwall and there is Powerwall Plus. While in Powerwall, this is a lithium iron phosphate battery that you can utilize into your home and you can connect it to various type of inverters. The Powerwall Plus features an inverter as well. So it is basically an all-in-one kind of solution. So we have the details on Powerwall and Powerwall Plus on our blogs as well. You can go there and you can study for yourself. The more the details are present in the blog. The next question we have from our client is, are portable power packs worth it? What I understand with this question is that he's asking that are the portable power stations batteries, that kind of batteries, worth it? Basically, any kind of batteries really depend upon which type of application you are going to use it, right? So if you're going to use some batteries with an application that has like outdoor application and camping and stuff like that, you cannot use your home power wall or like the lithium rack to take it to outside applications yet. You definitely need a smaller solution that has the AC ports with it as well to operate others, and that has DC ports as well. So the portable power stations are basically worth it when it comes to outdoor camping activities and other applications. The next question is, the next question we have is 10 kilowatt battery enough to run a house? To answer this question, I would really need to know what is the total watt rating of the house. For example, if you live in a house where you have like a total watt rating of like 1000, I'm just giving an example, it's not realistic. If you are consume 1000 watts of anything, even 1000 watts of like just an AC or something like that, so you're gonna have to calculate based on how many number of hours you run those applications. For example, you run one AC, you run one tube light, or you run one fan, and you run a fridge, you run any other steam iron, stuff like that, and you have like five of those in your house. You need to calculate the power consumed by each and every appliance one at a time, and then you're gonna have a total of how many watt you use in your house, and then you're gonna take that watt and you're gonna multiply it with hours. How many hours in a day, in a particular day, you use those appliances continuously. So for example, if you use those appliances continuously for 10 hours every day, you can take that watt, maybe it's like 10,000 watt, you multiply it with 10 hours, and then you get how many watt hours you consume in one day. Based on that day, you want to know now how many kilowatt hour battery should I need to support that kilowatt hour rating. So if your kilowatt hour rating comes to 10 kilowatt hours or less, you can certainly use a 10 kilowatt hour battery. If it's more than that, then you need to consider another battery. To calculate how to calculate your home load and how to basically check out what type of power, how much power you consume every day, you can go to our website, you can read the blog, and you can do the calculations very easily. So this is it for the questions today, and I believe that we have a very good session today. Furthermore, if any questions arise, we can discuss those into our next live show as well. If anybody of our viewers have any questions, we can answer those right now, and I'll catch you in the next one for sure. So this is it for today, guys. Thank you so much for listening. And if you have any questions, you can post it on our website, you can post it here when during the live show. You can post in your inquiries if you require any type of lithium batteries, We are a OEM lithium battery manufacturer based in China. We have been working in the industry for the last 10 years, and we provide premium quality lithium iron phosphate battery packs for various type of applications. So go to our website, check out the website, check if you find the product. If you don't, just put in the inquiry. We can have the product designed for you as well. We do OEM customization all the time. So please visit our website, check out the products, put in the inquiry, and one of our sales engineers will contact you. Thanks for having us on this live show, and see you next time.